So this is me. I'm Olivia Vane. You can find me at oliviavane.co.uk. And I'm a research software engineer working at the British Library. And I work full-time on a research project called Living with Machines, which is a big digital humanities research project between the British Library and the Alan Turing Institute. And it's a sort of big collaborative project. We've got software engineers, data scientists, but also historians, curators, linguists, and we are applying data science techniques to sort of large-scale digitized archives of the 19th century, so digitized newspapers, census records, maps, to investigate the lived experience of the Industrial Revolution in Britain. So that's what I've been doing for the last couple of years. And I'm a data visualization specialist on the project. I'm making visuals, making interfaces. And then before joining the British Library, I did a PhD at the Royal College of Art in London, which was in data visualization design for cultural heritage collections. And I did a whole range of projects with different institutions. So with the Wellcome Library, with the V&A Museum, the Smithsonian Design Museum in New York, and also the Swedish National Heritage Board. And you're going to see some of these projects as examples coming up in the presentation. I've just got a few examples of projects I've worked on at the bottom of the slide there. So timelines, text visualization tools, maps, sort of a whole range of data visualizations to cultural heritage data. So it's a good place to start. What is data visualization? Data visualization can be defined as the use of visual representations of data sets in order to amplify cognition. So really, it's a thinking tool. Through creating visual mappings of data, a viewer can see patterns, trends or anomalies, constancy or variation in ways that other forms, text and tables, do not allow. So the core idea here is that the human visual system is really, really powerful. We're really good at spotting patterns, spotting outliers, and it means that we can spot things, we can reason with data, we can spot these patterns that we can't see if the data is presented in other ways, in text or in tables. So yes, it's a thinking tool. This is a really nice illustration of the power of data visualization. This is a classic example. This is Anscombe's Quartet. And it's an example created by Francis Anscombe, who's a statistician. This is from the 70s. And essentially, Anscombe's Quartet is 4 data sets that you can see here on the left that all have identical summary statistics. So the mean, the median, the standard deviation, the variance is all the same. But if we were to graph the 4 data sets, we can see that actually each of them has a very different distribution. In some cases, it looks like there's a linear relationship, but we can also see that for data set 3 and for data set 4, that there are outliers which are completely skewing our summary statistics. So there can be features in your data which go unnoticed without visualizing it. And this is one of the the purposes of data visualization, is really to get a sense of what your data looks like, so you don't trip up on having outliers like this. So why do data visualization? Data visualizations can be used to facilitate the exploration and analysis of data in order to arrive at new discoveries, and or to communicate existing insights, knowledge, or arguments. So there's really kind of 2 sides to why we visualize data. There's exploring and analyzing our data. There's also communicating, and that's, making an argument, building a narrative, communicating existing knowledge to other people. And this is sort of a spectrum. And we're going to be stepping through later what exactly this means in the cultural heritage context. So I thought, since this is looking at is in the digital humanities and cultural heritage, that it would be really nice to spend just a little bit of time looking at the history of data visualization, because creating visual representations of information really does have a long history. I think that often people think data visualization, data science, this is a really new kind of whizzy thing that's only, that happens on computers, and actually this is a tradition with a very long history. And this is a quote from Michael Friendly, who's done a lot of research in the history of data visualization. And he says, it's common to think of statistical graphics and data visualization as relatively modern developments in statistics. In fact, the graphic representation of quantitative information has deep roots. These roots reach into the histories of the earliest map making and visual depiction, and later into thematic cartography, which is sort of data maps, statistics and statistical graphics, medicine, and other fields. Along the way, developments in technologies, so printing and production, theory and practice, and observation and recording enable the wider use of graphics and new advances in form and content. And the British Library, in fact, had an exhibition in 2014 that was all about really the history of data visualization. And you can see, yes, this is an image of the exhibition where they were contrasting historic examples from the library's collection with contemporary examples of visualization being made today. This is a graphic that is again from Michael Friendly, where he's charting a sort of development, the history of data visualization. And I'm just going to step through some examples. What I did want to say here is that these examples, it's very much, there's sort of all Western examples, and that's really kind of been sort of the focus of looking at the history of data visualization so far, but there's increasing work at the moment looking sort of outside the Western canon, which is really, really exciting, and I'm hoping to see more of that in the near future. But really, sort of the earliest seeds of visualization arose in geometric diagrams, in tables of the positions of stars and other celestial bodies, and in the making of maps to aid in navigation and exploration. So this is one of the earliest sort of graph-like diagrams. It's from the late 10th, early 11th century. It's from a manuscript, apparently text from monastery schools, and we don't know who the author is, but it looks like it's sort of multiple time series for the changing position of different heavenly bodies over space and time. So you can see at the far left, these little kind of sunburst graphics are labeled Venus, Mercury, Saturn. And the vertical axis is the inclination of the planetary orbits, and the horizontal axis is time. And there are some strange things in this diagram, which means it's not, it doesn't, I don't think it exactly is a graph, but it certainly looks graph-like. If we jump forward to the 1600s, this period was the birth of the scientific revolution, and important questions of the day concerned measurement and theory, and this was the driving force for a lot of visual representations. So this example is the work of Christoph Scheiner, who was a contemporary of Galileo. And Scheiner was looking through telescopes to track sunspots. For each telescopic view, he recorded the positions of sunspots seen on the sun in these multiple small graphics. So this graphic becomes both a record of his observations, but also a means to analyze those data. And this is actually, it's a very early example of a technique called small multiples, where you repeat related plots within one view so that you can make quick comparisons of different plots of data. And it's a really effective and I think very beautiful piece of visual design, but unfortunately Scheiner had the wrong theory in this case. He thought the sunspots were satellites around the moon as opposed to some other phenomenon. Shortly after that, we find what's considered to be the very first statistical graphic. This is by the Dutch astronomer and cartographer Van Langren, who plotted onto one graph different estimates of the longitudinal difference between the cities of Toledo in Spain and Rome from different sources. And if you tip your head to the left to read the annotations to the side of the graph, you'll notice that one of the measurements is from Mercator of the Mercator map projection. There are kind of two clusters of observations, but Van Langren places the label for Rome in the middle. He's kind of basically taking an average, and it's quite a nice visual technique, because obviously the width of the label Roma means that he's sort of suggesting there's an uncertainty in the measurement, because it covers a width. But unfortunately for the astronomers and the cartographers of the time, they were all wrong, and actually the measurement, which I've put a red line, is actually here. So due to the bias in measurement technologies of the day, all of these sources overshot the actual longitudinal difference between the cities. This is a map from 1685. This is actually included in the 2014 British Library exhibition. And it's a map of ocean currents. So it's illustrating ocean currents as understood at the end of the 17th century, based on the observations of explorers and mariners. And it's a picture formed on the basis of incomplete information, but it gives a sense of really of how much effort was made by early cartographers to try and make sense of the limited data that they did have without the visualization tools that we have today. And I really like this example because I think it has a really amazing texture. It almost sort of looks like fur, and it's really sort of suggesting to us the different visual forms that can be used to represent certain kinds of information. And we'll see a modern example later that looks a bit like this. But things really get going from the 19th century with the rise of capitalism and the rise of the bureaucratic state. And it's really these two developments which result in a new wave of data. So people keeping track at a larger scale than ever before in commerce, inventory, the movement of funds, and also the administration of government. So understanding the constituents of one's population. And this resulted in a need for new ways of representing and reasoning with all of this data that was being created, and led to what has been called the golden age of data visualization, which is the latter half of the 19th century. And you can see that's kind of, there's a peak in our diagram there for the golden age. And so it's exactly this kind of data. So this is trade data that was visualized by the Scotsman William Playfair, who is considered by some to be the father of statistical data graphics. And he was the first to invent a number of modern statistical plotting techniques. So in this case, the line chart, which is showing trade data for England. And that's just one of the many plots that Playfair invented. This is, another sort of amazing example. This is The Stream of Time by Friedrich Strauss. And this visualization is a timeline. It's actually only in the late 18th century that we see the first timeline designs. And this graphic attempts to visualize the universal history of mankind. So fairly ambitious. And you can see that these streams actually represent states and nations. So time runs from the top. And you can see the streams merging and splitting as we have sort of rise and fall of different states and nations. And that great big yellow pool in the middle is actually the Roman Empire. And I think this is an interesting example, because you can see that representing history is clearly been influenced by map making. This is using a geographical metaphor for visualizing time. This is another classic example. This is a diagram of the causes of mortality in the Crimean War, and it was created by Florence Nightingale. And it's been called a rose diagram or a coxcomb. So like the crest on the head of a rooster. And I think and to explain how you read this, in this diagram, each sector represents a month, and then they're subdivided into different colors. So the blue, we're seeing the number of deaths due to treatable diseases in the Crimean War. The red is the number of deaths due to war injuries, and then black is all other causes. And some might say that it's a bit of a confusing chart to read. It's actually the area of the sectors that correspond to the number of deaths, not the radius. And the area is actually measured from the chart's center, not just the visible color. But that wasn't necessarily what Florence Nightingale was really concerned with in this diagram. What was most important for her was to impress upon those who saw this chart the necessity for getting better medical treatment for soldiers in the Crimean War. So she really wanted to show these deaths in a really graphically evocative way. And she wrote about creating this chart, stating that she thought that if she presented this information as tables of figures, that it was never going to engage the public or affect decision making. So she wanted to create something really evocative, something really different, something really eye-catching to engage people with the data rather than sort of dry facts and figures. And so she was really sort of leaning into the rhetorical power of data visualization, which is again something we're going to see more of later in this presentation. This final example, this is a very famous example created by a 19th century French civil engineer called Charles Minard, who produced a large number of information graphics. And this is the figurative map of the successive losses in men of the French army in the Russian campaign 1812 to 1813. And it's a kind of narrative chart. So it depicts Napoleon's failed Russian campaign of 1812. And this has actually been described by some as the best statistical graphic ever made. And the reason for that is really the high number of different kinds of information that have been encoded into just this one graphic. And not only the number of different kinds of information, but they've been encoded clearly so that they can all be made sense of together. The six that I was looking for are the number of Napoleon's troops, which is the thickness of the line. So we see that it starts off really thick at the Polish border as they set off towards Moscow, and it gets thinner and thinner. And then when it's coming back, it's incredibly thin by comparison. So lost a lot of soldiers. The distance traveled, also the locations. We've got the place names on there. We've got the direction of travel, which is encoded in the color. So red is marching to Moscow and black is retreating. We've also got the dates of the retreat below. And we've also got the temperature during that retreat. So the dropping temperature of the Russian winter. So there's a lot of information all encoded. It's a very, very data dense display. So we've seen lots of historical examples, but what does the landscape of data visualization look like today? So there are lots of different graphs and charts. Different kinds of graphs and charts are used for different purposes. So to support comparison, to see distribution, to be able to inspect part of whole or sort of hierarchical data. So to be able to see what parts you have in a greater whole, to see trends over time or to see evolution. So you would pick different charts for these different purposes. Some of these will be very familiar. We've all seen a line graph, but there are also some more unusual examples that you probably won't have come across before, like a tree map, that one at the bottom right, which is used to show proportions within a whole. We also have maps. So these are symbol maps where we can show data on a map using dots, using the size of dots to encode quantities, or also to see links. We can create this is a type of data map called a choropleth, where you encode information using the color of areas of your map. So and I think we're all used to seeing these in the newspaper. These are maps of the 2019 general election in the UK, and we can see that we can use choropleths either to encode quantitative information. So the one on the left is using a quantitative color scale to communicate voter turnout, but we can also use it for category data. So on the right, it's for the different political parties. We can do strange things with maps. We can sort of distort the space. So the example on the left is where we've distorted geography so that every constituency is the same size. And the one on the right is a type of data map that we call a cartogram, where we've distorted space by some other variable. In this case, it's population. So the cities are distorted because there are far more people living in those small areas, and we can see the sort of the labour urban areas much better with this view. There are network diagrams. So this is an example of a project visualizing the digital German library, and this is a network interactive network diagram for the most prolific persons and organizations represented by the holdings of the library over a time period. There's also timelines. So this example on the left is from the Darwin Correspondence Project, and it's a timeline of Darwin's letters that he wrote and received, and you can see the volumes over time. But what's also really nice is the dots at the bottom, and this is actually an interactive example. So you can hover over and it gives you some information, but the dots at the bottom are milestones, important milestones in Darwin's life. The example on the right, again, is a timeline. It's from the same project as the network diagram in the slide before. It's the German Digital Library, and this is using a timeline to show the holdings in the library and the different types of holdings. So there are different lines and colors for the archives, for the library, for media, and for different other kinds of holdings. So we can see those over time. Example on the left, this is in line with data from the Cooper Hewitt Smithsonian Design Museum, and this is visualizing all of the items in their collection tagged coffee and tea drinking and arranging them by time, so we can see a sort of evolution of the design of those kinds of objects through time. And then the example on the right is a visualization by Florian Kreutley of the artists represented in the Tate collection, and this is visualizing their lifespan dates. So yeah, a different kind of timeline. These are some more unusual ones I think it would be interesting if you have a look at. So if you want to have a look at, you can have a look at one or two or all three of those, it doesn't matter. Have a look at these, and then these are just some questions to think about. So what would you call these graphs or charts or maps? Is that what you would call them, or would you call them something else? What does the visual representation make you think or feel about the subject matter? Are these easy to read? Are they easy to see patterns in the data? So yeah, this is the on the origin of species, the preservation of favored traces by Ben Fry. And this is a visualize of Darwin's Origin of Species, and it shows the evolution of the text over the various editions and the changes that he made to the text, the additions that he made to the text. And you can see this as an animation. This example, I think, is something of a kind of a Marmite example, and I think I saw in the chat that there's some differences in opinions. Some people really love this, and I think it's an amazing visual for sort of really hammering home that this was a text that really changed a number of times, and in particular we can see that, you know, chapter 7, this whole new chapter is added in the 6th edition. But for other people, I think they find it quite difficult to read. It's quite difficult to actually get at the text itself. So yeah, different people feel differently about this one. This is the wind map by Fernanda Viegas and Martin Wattenberg. And I could see, a lot of people in the chat were saying that they found this really, really easy to read. And I think this is it's a lovely example. It is interesting that it doesn't look like a scientific map at all. It doesn't look like the kind of thing you'd see on the Weather Channel. It has, and this sort of amazing moving fur-like texture, and actually quite similar to the 17th century ocean currents example that we saw when we were looking at the history of data viz. And this example has actually been exhibited at MoMA, so in an art museum. So I think that, and I would say I'd probably call these 3 examples artistic data visualizations. So we can see that data viz, it's not only about sort of science, quantitative, sort of data science work. It can also, there's an artistic area. There are sort of amazing artistic examples where aesthetics are really being explored, and the sort of the rhetorical function of aesthetics is really being explored. And this final example, and so there's a lot of love for the dendrochronology example in the chat, which is visualizing immigration history in the US. And I think, somebody did pick up on this in the chat. I saw that this isn't, I think, necessarily the best way of presenting this data if you were really concerned about legibility and being able to compare across years, because using the tree rings form, it does sort of distort your data year on year in terms of the area it's taking up. And you can also see that the different colors being used for immigration from different geographies, that they do sort of merge around the tree rings. So probably it would be, if you wanted something that was really legible for being able to make comparisons between years, you probably use a bar chart. But I think this is really going for something very different. This is using this sort of wonderful positive metaphor for immigration, of creating this sort of unified, beautiful thing at the end, which is depicting, you know, the population of the US as this evolved whole thing, and it's really sort of taking a different approach to the kinds of charts that you might use to present this data instead. So why make data visualizations of cultural heritage data? Why do we do this with humanities data? And I think that we can think of this in terms of for what kinds of different tasks are we talking about? Cultural heritage data visualization is really useful to support research activities. It's also useful for collection administration and management, but it can also be really helpful to support casual browsing and display of collections data as well. And we can also think about the various different kinds of user groups that cultural heritage data visualization is useful for. So, and this includes scholars who are working with collections, but also collection managers at institutions, casual audiences. So this is both in gallery, so, you know, thinking about having interactives installed in a gallery, but also having online experiences as well. And also for educators. So there's a whole range of different people, different users we're talking about, and a range of different tasks and activities that data viz is useful for with humanities data. And I think that we can think about there being this spectrum of use cases for data viz in cultural heritage, going from analysis of data on one side, exploration of data in the middle, through to presentation. So presenting existing knowledge, making an argument to people on the right-hand side. So if we start on the left with analysis. So visualizing cultural data can support analysis of collections by showing patterns that result from sorting, grouping, filtering, and other visual arrangements of the data to expose outliers, trends, and abrupt changes. And this is particularly productive for data sets too large to grasp or process otherwise. Visualization can help researchers ask questions of collections that would be too time-consuming to otherwise explore, so too time-consuming to approach manually. Analyzing cultural data through visualization can also assist in the administration and management of collections. So it can allow curators and collection managers to gain intellectual or physical control of a collection. And I spotted a question in the chat about defining cultural heritage, and yes, I do mean quite a wide definition here. So I'm really meaning data that represents the holdings of cultural heritage institutions. So anything from data that represents collections of artifacts, artworks, objects, texts, you know, books, newspapers, really a sort of a very wide, you know, archival material, data that represents all of these different kinds of holdings. So I'm going to step through a few examples of how data visualization can be used for analysis with humanities data. This is an example from a digital history research paper that was published recently called Networks and Opportunities, A Digital History of Ireland's Great Famine Refugees. And it's a really interesting project where the researchers were studying Irish emigration to New York City in the mid-19th century. So immigrants fleeing the Great Irish Famine. And the data they're working with are digitized records of the Emigrant Savings Bank in New York City, which was a bank where the Irish immigrant community opened lots of bank accounts. And what's really special about this data is that when you opened a bank account with them, you had to record where you had come from in Ireland, and down to sort of a really detailed level, you had to record which parish in Ireland you came from. So it's an incredible resource, giving us very fine-grained data about where these Irish immigrants were coming from in Ireland. And so the researchers here were really sort of interested in asking where were people emigrating from, and sort of what was the biggest driver. The sort of obvious first thing we might think of is surely it would be the places in Ireland where the famine was most severe was where we get the most people emigrating from. So what they did is they visualized these bank records and made a map to plot and see where people were coming from. And this is an example of a choropleth. So it's coloring areas of the map using data. This is using a color scale to show the per capita emigration rates of the different parishes, where the darker the green is, the higher the rate of emigration. And we can see that actually it's incredibly kind of speckled map. We have some, parishes that are really dark next to parishes that are really light. It looks sort of incredibly variable. And what the researchers then did is they separated the data, and they said, I want to see a map of the people who had emigrated pre-famine, and I want to compare that against the people who emigrated during the famine. And what they found was actually that the patterns of these two timestamps were really similar. We can see this example here, that actually there's a lot of similarity between the two patterns, which suggests that actually more important than the severity of the famine in various places in Ireland was actually whether there were people that you already knew from your parish who had already emigrated, who could help you, who could let you know what it was like living in New York. And that was a more important factor. And so they were able to see that by mapping the data. Visualization can also be helpful for archival appraisal. So this is another example from a research project which was exploring visualization for archival appraisal of large digital collections. So this is, so you can see the charts on the left are examples of a type of chart called a tree map. And it's a little bit difficult to see what's going on. So I've put a sort of a more standard example of a tree map at the bottom right. And what it is it shows you, it's for hierarchical data. So in this case, this is folders, digital folders with folders and files within them. So it's a hierarchy of folders and files, and you can see what is the number of items within particular folders. And example, the researchers have colored these little squares by the different file types. So this is a way of examining directory hierarchies and file type distributions. And they say, we hope to enable collection managers to notice trends and spot outliers in the course of better understanding a digital collection's composition. Because of the size of contemporary digital collections, data has to be presented in ways that facilitate understanding and enrich the analysis. So this might help you get a grip on a sort of a large data set that you've received, a large digital collection, and help show you the makeup of that collection. This is an example, one of mine that I worked on with colleagues on the Living with Machines project. This is a visualization project called Press Picker, which we created to support making digitization decisions at the British Library. So we were looking to digitize a number of newspapers held at the British Library. We had some budget to digitize some 19th century newspapers, but we needed to make a decision about which newspapers we wanted to digitize. And this turned out to be actually very difficult, because the size of the British Library newspaper holdings is very large, and the data is quite complex, and we were under some time pressure. So actually we realized that one of the most important factors in making this decision was the different formats the newspapers were held in the library, because that has big implications for digitization. So whether it's a hard copy, a sort of hardbound volume of the newspaper, or whether we're digitizing off a microfilm, which is a kind of film reel, which is much quicker and cheaper. So this visualization, which shows the library's holdings for different newspaper titles, and each line graph is showing the holdings over time is running horizontally of the different titles. And we've used color to show the holdings in the different formats. So we had a really clear sort of objective when we're working with this data, that we needed to know about the different formats of the titles. And so this was really helpful for making the decision about which titles were going to be the best ones for us to digitize. Visualization can also be really helpful for spotting errors in collection data. And I think those of us who've worked with collection data before, it's very normal that there are some metadata errors. Yes, it is, can be very, very difficult to create a perfect data set. This is a project I worked on with the V&A Museum. This is visualizing the Royal Photographic Society collection at the V&A Museum, which was a collection of historical photographs, really from sort of the advent of photography. And it's a little difficult to see in this small image, but essentially I'm visualizing the photographs horizontally by time, when were the photographs created, and then they are separated vertically into different bands depending on the photographic technique. So these are there's a whole range of different early photographic techniques. So the top band is albumen process, the next band is daguerreotypes, and so on and so forth. But you can see that there are, in the sort of blown up image at the bottom, we can see that there are actually a whole set of outliers which don't fit into these areas in the timeline where we can see lots of examples from a particular technique. And this was helpful as we realized that actually the two on the furthest right were metadata errors that we could correct. But of course, not all outliers are errors. Some are just genuinely outliers. And the middle, the one that's labeled number 1, the furthest left of the 3 was correct data, and was possibly the photographer revisiting an earlier technique at a later date. Similarly, this is, showing visualization can be really useful for spotting errors. So this was, I was doing some work with a collection at the British Library. This is the King's Topographical Collection, which is a collection of maps and prints, early maps and prints at the library. And just a quick visualization showing mapping all the data by time, we can see that actually there are some data points from later than the year 4000 and the year 6000 and 8000. So clearly something has gone wrong. And just quickly inspecting one of these examples, that the data says that the date of publication is 8179. If we compare that to the non-standardized data publication below, we can see that there's been a computer error parsing the day of the month that's ended up blending with the year. And actually that was the same pattern for all of these at strange later dates. So we were able to pick up on that. This example is from a project visualizing the Cress collection. And I think this is a really interesting example because it makes a point that visualizing collection data does not necessarily provide you with the answers to your questions. It can in fact raise more questions. So this is the Samuel H. Cress History and Conservation Database project, where visualizing the collection data, they say, facilitated a better understanding of the collection's origins, qualities, and donation patterns. And they made a whole series of different kinds of visualizations of the data. You can see that there's a map view here. There's also the scatter plot view on the left, and they had some further ones. In this paper, they describe that rather than the visualization answering pre-existing research questions, the trends revealed by visualizing the data more served as wayfinders for further exploration. So visualization can reveal trends in the data, but it doesn't necessarily give away what the origins of those trends are. So in the case of the Samuel H. Cress project, visualizing the provenance information of this collection led to a suggestion, a curiosity that might not have emerged from study of the collection data itself. And I think this is, yes, a sort of important thing to understand, to sort of manage expectations when you're visualizing data, that there may be patterns that you pick up on, but the context of why those patterns are there may not be in your data set. And I found this is why it's incredibly important and valuable to work closely with experts in that collection, be it historians or curators who are incredibly helpful, and because they are so knowledgeable with the collection, to be able to help you interpret what it is that you're seeing, because that context may not be in the data set, it may be somewhere else. Similarly, this is an example, one of mine. This is a project called Dive into Color that I did with the Cooper Hewitt Smithsonian Design Museum in New York City. So this is a museum of historic and contemporary design. They have a collection of a whole range of design objects, furniture, metalwork, textiles, prints, ceramics, and I worked with the museum to create this interface, Dive into Color, which visualizes the collections data, the holdings of the museum, by color and by color harmony. And I display the data, as you can see, on a timeline, which means that you can spot color innovations and trends. You can spot fashions in color at various points in time. You can see, for example, that there's very, very few or no early purple objects, because the difficulty and expense of producing purple hue before synthetic dyes in the 19th century. So you can pick up on these kinds of things. But this example here, I'm visualizing complementary color harmony, which is opposites on the color wheel. And color harmonies are combinations of colors which are said to look particularly pleasing to the eye. And so we're interested in how these harmonies have been used by different creators and designers through time. And this interface was created to complement an exhibition all about color theory at the museum. So this is visualizing the blue-yellow color harmony. And it might suggest that there is something, interesting happening sort of in the early 20th century. We can see that there's a whole sort of column of results of sort of very vibrant blue and yellow. So yeah, is there something interesting happening there? But firstly, it's important to think that this isn't a very large number of data points here, and some of the early examples that we have are actually textiles, and their colors may have faded over time. So this isn't necessarily what they looked like when they were made. So it could be sort of a range of factors which contribute why we're seeing this kind of peak of results in the kind of 1900 to 1950. And it's not clear whether it's some important trend happening at the time, or whether it is these other characteristics of the data which are not necessarily a historical trend. The sort of middle section of this spectrum is using data visualization for exploration. So analysis and interpretation are only part of the scholarly process. And for researchers working with cultural data, an equally important task is that of locating and assessing new material. Visualization can also help to support exploration of collection data for these kinds of activities. And it can be really helpful to provide a kind of a unifying and structuring effect to surveying material. And in particular, interactivity has special potential to offer multiple views on cultural data. So this is both about getting a better understanding of the shape of your data set. If you're a researcher, it can be really helpful to know what you're working with, and that can help you to refine your research questions. What are the kind of sensible things that I want to ask with this data set? But equally, data visualization can be helpful for exploring data as a sort of a generous way to present data to the public to help them get a sense of the contents of a collection. So this is just this is a nice example of the MoMA collection. So this is modern art, and this is just a scatterplot which is showing the 14,000 artists represented in the collection, where birth year is going horizontally and the number of artworks is going vertically, and they've also sized the dots by the number of artworks. So this just, very quickly gives an idea of what's in the collection, who's represented in the collection. This is another fun example. This is The Word Tree, it's called, by Martin Wartenberg and Fernando Viegas. And this is a way of exploring texts where you can look at repeated patterns in a text. So this is visualizing Alice in Wonderland, this example. And this tree visualization is showing what are the different patterns and the different sentences in Alice in Wonderland, where the sentence begins with Alice thought. And so we can get a sense of the patterns of the text and reuse in the text. And we can just sort of throw things into this interface and see what comes out. This is another example from Florian Kreutley. This is visualizing the Tate collection. And I think this is a really great example where Florian just wanted to visualize the time distribution of the Tate, and found that there was, this sort of this large peak sort of around 1800. And what he discovered was that actually 57% of the Tate are artworks created by Turner. And I think that we might expect that Turner is a very important British artist. We know that the Tate has a lot of Turner artworks, but it seems that seems like a lot, like more than half of the entire collection is Turner. And so Florian sort of delved into the data to try and figure out what was going on, and actually found out that what was going on here is that the Tate has a large number of Turner's watercolor sketchbooks, and they've chosen to catalogue each page of these sketchbooks as an individual item in their collection database. So these sketchbooks actually are contributing a huge number of items in the database, because they've all been catalogued individually. So it's really, this is making a point that cataloguing choices can have a huge impact on numbers in your data set. Those choices have big implications. And similarly, this is again Florian Kreutley. Cataloging approaches really do shape what we see in visualization. So this is creating timeline visualizations of the date distributions of different collections. It's Tate at the top, and then the Oxford Beazley archive in the middle, and Cooper Hewitt at the bottom. And what we're seeing is the different strategies these institutions use for dating their items. So the Tate prefers exact years, the Beazley archive likes to choose 50-year intervals, and Cooper Hewitt likes to date by the decade. And so you see that it's actually these cataloging choices have really made a big difference to the shape that we see when we visualize this data. The other side of exploration is visualization can be a really powerful way of delivering collections to more general audiences who are interested in browsing and exploring. And so this, the idea of generous interfaces, which is really caught on, is a term that was coined by an Australian academic called Mitchell Whitelaw. And the idea here, and so this is more focused on casual audiences rather than scholars and researchers, is that they're really an alternative to using a search bar. Mitchell Whitelaw describes that if you were to go to a museum, you can go and you can wander around and see everything that's on display. You can wander through all the various rooms. And why is it that when you come to, say, a museum website, often you're faced with a search bar where you're expected to know what's already in the collection to be able to make a search to receive anything back? It would be like going to a museum and you have to tell the person on the desk, you know, exactly what you want to see, and then they'll sort of bring you some examples. So the idea of generous interfaces is that we can use, we can design interfaces that show rather than ask, and can show sort of the range of contents of a collection, the shape of a collection, and can help people to explore and navigate without needing to know what's already in the collection. So this is really all about exploring and browsing, and being, yes, sort of generously shown what's in the collection without needing to ask. So this is a nice example. It's called Explore Australian Prints and Printmaking. And again, we see it's got a timeline at the side, which is showing the holdings for various decades, but we're also getting this kind of patchwork of some of the examples of prints from that decade. This is an example called Manly Images. And so the Manly Local Studies Image Collection is a set of around 7,000 images that document the history of the Manly area from the 1800s to the 1990s. The interface lets you explore the collection by title or decade, and its aim is to provide a rich, engaging overview of the collection and to encourage exploration and discovery without the use of search. So again, it doesn't have a search bar as the first thing you see. And this, we've seen this kind of chart before. I'd call this a tree map. It's the sort of the rectangle squares that are really useful for seeing part of a whole. But the way that this has been designed, it doesn't look like a graph or a chart to me. They've used example photographs to fill all of these boxes. And so it's a really generous way to see what are the various different kinds of objects, different themes in the collection, what are their relative numbers, and also to see some examples without me needing to know anything about this collection. And I think it's very inviting. It doesn't look like sort of a dry chart. And a further example, this is called the Corley Explorer, and it's using a map in this case. So this is a collection of over 60,000 photographs of houses in Queensland from the 60s and the 70s. And so the collection data, it makes sense in this case because all the photos have addresses. They're shown on a map, which is an easy way to navigate around and explore the collection. And then the final side of this spectrum, going from analysis exploration, is presentation. So visualization of cultural data can also be used for presentation and display. And there are both static and interactive examples. So it can be used to communicate an argument or point of view, but also curated paths and sequences can be employed to present narratives about a collection. So this is an example from the Helsinki Design Museum. It's a timeline visualization, and it shows the number of pieces in the museum's collection designed by male designers at the top and female designers at the bottom. And so this clearly has a very particular agenda in the presentation. They're wanting to show the disparity between items created by male and female designers in the collection. It has a very particular point of view that it's making in this presentation. This similarly is an example from MoMA. It is a network visualization that accompanied an exhibition that was all about, it was called Inventing Abstraction. And in this visualization, it's mapping documented relationships between artists featured in the museum's Inventing Abstraction exhibition. And the visualization means that you can explore these connections. But I think what's interesting here is that as a whole, this is also making an argument about the exhibition that abstraction was not the inspiration of a solitary genius, but the product of network thinking. So the choice of the visualization type is itself making an argument, making a point about this art movement about this exhibition. This is an example of mine. This is a visualization of soldiers' portraits from the First World War. And this is a collection from the Imperial War Museum in London. And in this, I'm cascading down the portraits at the date of death during the First World War. So again, this is an artistic way to present the data. It's it's taking an emotional view on the data rather than sort of graphs or charts for reasoning about exact numbers. So again, this is for communicating. This is more sort of an artistic interpretation of the data. I think that when we talk about data visualization for humanities data, for cultural heritage, I think that a lot of the time people immediately think that when you're creating graphs and charts, it's all about taking the distant view of data. It's about taking a very stepped back summary view of data. And this example is the Google Ngrams viewer, where we're looking at the number of times that Frankenstein or Albert Einstein or Sherlock Holmes are mentioned in huge numbers of texts and plotting that over time. But the distance between this aggregate view and the individual book or the individual page can feel like it's very, very far away. So I think there's sometimes a feeling that visualization is all about taking the macro view, the zoomed out view, where individual records and artifacts and collection items are all abstracted away. And I think that there's sometimes a worry that when you do data visualization, you're losing all of the detail beneath the kind of the smooth curve of the graph. But that doesn't necessarily have to be the case. I mean, visualization is incredibly useful for dealing with volumes of data that are too large to get a grip on manually, but there are ways of getting a closer view and also moving between the sort of abstracted and the detailed view. So this sort of slightly strange morphing example at the top left is a visualization called Reading Traces, visualizing it's Theodore Fontaine's reference library, and they're visualizing his marginalia. It's his Theodore Fontaine's annotations in the books in his reference library. And what this visualization does, it allows you to move from the stepped back overview of the different themes of those annotations across each of the books, and then being able to zoom in and to get to individual pages and seeing what those annotations were on the individual pages. The one at the top right, visualizing the Royal Photographic Society collection, that's again one of mine, where I've used the individual photographs as the data points, so you can still see what it is that the data represents. Bottom right, that's one that we saw earlier on the origin of species. That is visualizing just one book. It's showing the evolution of one text over time. And the bottom left is an example from the Cooper Hewitt Design Museum, where they created timeline visualizations for individual objects, where it's showing the history of one object and the history of it being acquired by the museum, being photographed, all the things that have happened. So it's not, visualization is not only about taking a really sort of stepped back abstract view. There are ways of getting to the details, to the individual objects, and moving between the two. I think that similarly, there can be a feeling that data visualization is all about, it's all about numbers, it's all about the quantitative, it's all about quantities and counts. What about the qualitative aspects of collections? And there are ways of really focusing on the qualitative aspects of data as well. So these examples are all examples of media visualization, where you use sort of very small sort of icons representing items as themselves data points. So the example on the left is one by Lev Manovich, where he's visualized all the covers of Time magazine from 1923 to 2009. And we can see, because we can see, even though they're very small, we can see all of the images of the covers, we can see them changing from black and white to color. We can see the border, the white border on the cover disappearing. We can see particular color palettes that were more dominant for particular periods of time, particular decades. You can also do this with text. This is the word tree example, where you can actually use the text itself as what it is that you're visualizing, so that you can read the text, you can see what it actually says. There's a whole set of text visualization tools at the Voyant Tools website, which is all about using visualization to investigate texts. Another thing to think about is, this is a conclusion that came out of the Visualizing the German Digital Library project. The researchers who worked on this, they set out to create a visualization which was really a kind of an overview of the German Digital Library collection, which gave you a sense of what was in the collection. And they found that actually the better strategy was to create a whole series of different visualizations. They found that one view is not enough, and they needed different perspectives on the data to get a kind of rounded, nuanced view of what was going on. So it may be that you don't want to think about what is the one that I want to make. Maybe I need a collection of complementary visualizations to get a sense of my data. And this is a really nice example of that point by a former colleague of mine at the British Library, Jan Ryan, who created a whole series of visualizations of the British Library newspaper holdings. And he looked at the data set from all of these different angles, what's been digitized, what hasn't been digitized, where geographically are these titles from, which countries, which counties, how long did the newspapers run for, what were the stretch of their publication history. So there are all of these different perspectives that you can get on one data set, and sometimes you need a whole collection of visuals to get a sense of what's going on. And it's really journalists who are absolute masters of this, of creating a series of visuals, combining multiple views and using animation and ordering to really create a narrative and an argument about data. And my final point, just as we're finishing up, coming to noon now, is dealing with uncertainty in cultural heritage data. This can be a sort of a pretty common problem. It's one that I dealt with a lot in my PhD when it came to dates in cultural collections. Often we don't have definite dates. How is it that we visualize data that is uncertain? One strategy is to, this is an example from Florian Kreutley, to use these error bars to really remind people that there is uncertainty in this data. We don't quite know the dates for these items, but you have to be very careful that if there's a lot of uncertainty in your data, do you want that to be part of the visualization? Because it could become the whole story. You don't want your visualization to be entirely error bars and you can't see anything else. So are there other strategies for dealing with this that are not sort of so overwhelming? And there's a nice example here, conveying uncertainty in archived war diaries with this technique called Geoblobs. And this is a project from the National Archives working with a collection of handwritten First World War diaries, which document the story of the British Army and its units on the Western Front. And they wanted to create visualizations which were able to express the temporal and geographic uncertainty in visualizing the events described in the diary. So you can see they created these sort of fuzzy, blurred shapes, which suggest areas on the map, but are not completely definite. So there are ways to tackle these issues, and lots of interesting work happening in uncertainty at the moment. Which brings me to the end of today's session. So I'm happy to stay on a little bit longer if there are any questions that anybody has. This is quite a tricky issue. I found in my work that it's very difficult to create a visualization that can cater both for experts who really want to analyze a collection and visualizations that are suitable for a general audience where you really want to add a lot more annotation and narration. So I found in my experience, you end up having to create two separate things. And that doesn't mean you're entirely doing sort of fresh work for both. You can, there can be overlap in your design and you can be making a variation, but I've found from experience that creating a design that caters for both is, that caters for both successfully is very, very difficult. Definitely, I think that has a big effect on the variety of colors that we see in the collections. It's simply that synthetic dyes, synthetic pigments really opened up this spectrum of colors that simply weren't possible or weren't economic previously. And the Cooper Hewitt collection actually includes some scarves, which are examples which were dyed with Vane, the first synthetic dye, this sort of mauve, pink, purple color. And what was an interesting thing that happened with this interface was that all of the colors for these objects were extracted computationally using a sort of a computer vision tool. The collection is about 200,000 objects. So if you'd ask someone to manually go through and add all the colors to the records, that would have been completely unfeasible. So it was done automatically, and the algorithm which picked out the colors was pretty good. Most of the time it gave you results which seemed accurate, but it wasn't perfect and it did miss some things. And actually the Vane scarf, which is a really, really important moment in color history, the color algorithm didn't pick out the Vane color. It sort of picked out much softer colors that were just part of the photograph. And so that was a really interesting moment in this project, talking with the curators who are saying, this is a really, really important moment in color history. It has to be, we really want it to be part of the interface, but because we use this automated approach, it had actually missed that. And there are, in addition to the availability of artificial pigments, there are also sort of significant moments in color history of particular texts that were published. So I think it was a chemist called Chevreul, French chemist, who wrote a text all about color harmonies, and suggesting that the sort of the complementary color harmony was really attractive, and this text was really influential with artists and designers. And so, you know, we looking at these timelines are wondering, are, you know, some of the shapes that we're seeing responding to particular texts that were published, which influenced what designers were doing and making. Really important question. And I don't know, it wasn't recorded in the data whether they were. And similarly, this question of how accurate was this algorithm picking out the colors? Sometimes it was missing things and not getting them completely correct. For this interface, which was designed it went into the exhibition all about color theory at the museum, and we felt that trying out the interface ourselves and judging the results, we were very happy that for a general audience, we thought it was doing a really successful job. It was picking up on these patterns and trends. It was showing lots of interesting examples. But for researchers interested in sort of color distributions across the collection, that may not have been good enough. And this question of were the images calibrated appropriately becomes much more important. So that might have been, yeah, a big problem for them.